Hello students, welcome to Swapna physics classes. In this lecture I am going to teach you one more essay question, 8 marks question for your TS intermediate second year IPE examination. Okay, and this question is from waves chapter, and the question is how are stationary waves are formed in closed organ pipe. Explain the various modes of vibrations and obtain the relation for their frequencies. We have to find out the various modes of vibrations and we have to find out the frequencies whenever a stationary wave is formed in the closed organ pipe. And coming to the organ pipe, what is the organ pipe? It is a cylindrical tube. It is a cylindrical tube having an air column. And coming to the closed pipe, which is closed at one end. The organ pipe is closed at one end and opened at the other end. And how are stationary waves formed in this closed organ pipe? Let's see. For this purpose, I have generated a sound wave and allowed to pass this sound wave through this organ pipe, closed organ pipe. This is the sound wave which I was generated, and this wave incident at the other end of this organ pipe, and this wave gets reflected. This wave gets reflected, and whenever the incident wave and reflected wave having same angular frequency, amplitude, time period and in phase, whenever the incident ray and reflected wave are in phase and having same amplitude, angular frequency and time period, gets superimpose each other. So gets superimpose, nothing but overlaps each other. Okay, overlaps each other to form the stationary waves. To form stationary waves. This is how the stationary waves or standing waves are formed in closed pipe. Now let's see the various modes of vibrations and the frequencies at which the harmonics are formed for a closed organ pipe. Okay, in case 1, fundamental frequency. Fundamental frequency. The first frequency at which harmonic is formed. Okay, which is known as first harmonic. Fundamental frequency is known as first harmonic. Okay, we have to find the first harmonic or fundamental frequency, new one. For this purpose, I am considering a closed organ pipe, and for fundamental frequency, we require one node and one antinode. One node and one antinode. Okay, and always remember at the open end an antinode is formed, and at the closed end a node is formed, always. Okay, now what will be the length of this pipe now? Length L is equal to lambda by 4. I am taking it as lambda 1. Lambda 1 is equal to 4L. Lambda 1 is equal to 4L for this fundamental frequency. Okay, now the frequency nu is equal to V by lambda, where V is the velocity of the wave and lambda is the wavelength and nu is the frequency. Okay, for fundamental frequency I am taking it as nu 1 and lambda 1. Velocity remains constant throughout the same medium. Okay, now this nu 1 is equal to V by what is lambda 1? It is 4L. This is the fundamental frequency or the first harmonic at which a standing wave or stationary wave is formed. And coming to the case 2, let's find out the first overtone. Let's find out the first overtone. For first overtone, we require one more node and one more antinode. One more node and one more antinode. That means we require 2 nodes and 2 antinodes for first overtone. Okay. So now the diagram will be this one. Okay. A sound wave is traveled through this closed pipe and get incidented at one end and then after reflected back. Okay. See here, we require 2 nodes. We require 2 nodes. We require 2 nodes and 2 antinodes. 2 antinodes in case of first overtone, and the length will be this is lambda by 4, and from here to here we will have lambda by 2. I am taking it as lambda 2. I am taking it as lambda 2. mu1 is equal to V by 4L. Equation number 1. This is the first or fundamental frequency. Now the length for first overtone, length of this organ pipe, closed organ pipe for first overtone will be equal to lambda 2 by 4 plus lambda 2 by 2, and I am taking the LCM here. Here we have lambda 2 plus 2 lambda 2 by 4, which is equal to 3 lambda 2 by 4. Therefore here lambda 2 is equal to 4 into L by 3. Okay, and the frequency nu2 is equal to V by lambda 2. You have to substitute this lambda 2 in this equation. Therefore the frequency will be equal to V by 4L by 3. Therefore nu2 is equal to 3V by 4L. 3V by 4L. What is V by 4L? V by 4L is nothing but nu1. Therefore nu2 will be equal to 3 nu1. This is equation number 2. Equation number 2. See, if you observe carefully, here we have nu1 and 3 nu1. Next harmonic is formed at 3 nu1, 3 times of the fundamental frequency. Okay, here there is no second frequency. That means second harmonic is absent in this case. We have third harmonic. Therefore this first overtone is also known as third harmonic. Third harmonic. Okay, and coming to the next harmonic. What is the next harmonic we have? Let's see. So for this purpose we require one more node and one more antinode than the first overtone. This overtone is known as second overtone. Okay, and what is the harmonic for this second overtone? Let's see. Okay, therefore we require 3 nodes and 3 antinodes for this case, and diagrammatically here a wave is produced and we require 3 nodes, 3 antinodes. First node, 1, 2, 3 nodes and 3 antinodes. Okay, and the length of this waveform will be equal to, let's find out, this will be lambda by 4, this will be lambda by 2, this will be lambda by 2. Okay, now the length will become L is equal to lambda by 4 plus lambda by 2 plus lambda by 2. Here I am taking the wavelength as lambda 3. Lambda 3 for the second overtone. And it will be equal to lambda 3 plus 2 lambda 3 plus 2 lambda 3. I am taking LCM here. Therefore the length, the total length for this waveform will be equal to L is equal to 5 lambda 3 by 4. 1, 2, 3, 4, 5 by 4. Therefore, the wavelength lambda 3 is equal to 4L by 5. And we know that the frequency nu 3 will be equal to V by lambda 3. V by lambda 3. Now you just substitute this lambda 3 in this equation. Therefore, this nu 3 is equal to V by 4L by 5. Therefore, nu 3 is equal to 5V by 4L. What is this V by 4L? V by 4L is nothing but nu 1, right? Therefore, nu 3 will be equal to 5 nu 1. This is equation number 3. Just observe here, 4 nu 1 is absent. Fourth harmonic absent. Okay, here we have fifth harmonic. The second overtone is also known as fifth harmonic. Okay, second overtone or fifth harmonic. If you observe carefully here, for a closed organ pipe, the harmonics we have are odd harmonics. Those are nu 1, 3 nu 1, 5 nu 1, 7 nu 1, 9 nu 1 and so on. Okay, if you observe carefully and write the conclusion. For a closed organ pipe, the stationary waves are formed at odd harmonics, and nu 1, nu 2, the frequencies are equal to 1:3:5 so on. They are in the ratio of 1:3:5 so on. Okay, here I will end this lecture, and whoever didn't subscribe to my channel, please subscribe to my channel and share with maximum number of people. Okay, bye.